Uh, Thank you all for taking time out of your Tuesday to meet with us here today. It is our pleasure to present this information to you. Let me get that off the screen there. My name is Larry Waters. I'm going to introduce myself in a section. What we're going to do today is we got our introductions done. We're going to set the stage on why we're electrifying now. That's going to take a minute or two. Couple of minutes on how heat pumps work for those inquisitive of you out there that are curious on how this technology actually works. And then we'll show you some heat pump options for HVAC and heat pump options for water heating. But I just want to touch on something that April said. We see, I've been in this business for 40 years, and incentives come and incentives go. If you guys are thinking of doing this, there is no better time than right now to get this done, because the incentives that you see today might not be there if you wait. We had a couple of the programs up near us. We're up towards the North Bay in California. A couple of the programs just demonetized pretty significantly. And some customers that were waiting for a small additional amount of money ended up missing out on a big chunk of money. And it can completely change the trajectory of their project. So just, there's no time like the present on this stuff. Really quickly, I know I look like I'm 26 years old, but I've been in the HVAC trade since 1982. I was young at that point. I didn't start when I was 40 or anything. I was actually in the trade before the first cordless drill. There's some certifications in our industry called NATE certification. That's National or North American Technician Excellence. I've been certified through that program for 24 years. And I've been a BPI certified building science analyst since 2010. And I started installing nothing but heat pumps back in 2015. And I was installing heat pumps for people that called me and wanted a new furnace, because when you learn about heat pumps and you find out what they can do, how much energy they can save, and how comfortable they can make you, they're a way better investment than getting another furnace, especially in today's day and age. That led me to founding this company, Electrify My Home, back in 2020. I was working for another company there doing a lot of heat pumps and electrification work, but they didn't kind of want to kick the gas. And I said, I want to pass on gas. So I'm going to start this company. And now that's actually one of our taglines. If you want to pass on gas with Electrify My Home. So we're a mission-driven company. Our mission is to provide the most efficient, cost-effective electrification solutions. Be a good steward of your electrical panel. And it's important that you find a contractor to work with that's going to be a good steward of your electrical panel, because you don't want to make decisions up front that may cost you a lot more in electrical panel upgrades. And then part of our mission as well is to train and influence other contractors and homeowners across the state to understand the same. So we're really happy to be with you. Really quickly, why electrification? So flames out in California by 2030. In the Bay Area up here, the Bay Area Air Resources Board just passed a initiative. I don't know if you call it an initiative, but they passed a ruling that they are no longer going to sell gas water heaters past 2027 up here, and gas furnaces past 2029. And across the entire state, we have a complete ban on those two appliances in 2030. And it's okay that this ban is in place. This is a good thing. Heat pump systems are more efficient and can be more comfortable and less expensive to operate if you get the right one installed. So we're going to talk a little bit about that. Where we are in this massive task that we have to overdo is 90% of California homes rely on gas for heating their house. And there's 3.4 million houses in California with no AC. And you guys along the coast down there, there's probably a fair amount of you that don't have AC yet. And, you know, the climate is changing a little bit. Maybe getting a heat pump is going to give you a little relief in the summer too, and some better operating efficiencies in the winter. So might be a win-win, but we got a long way to go on this project. The topic of the day is heat pump products. We're going to talk about heat pumps to cool and heat your home, cool and heat your water, and a couple of other technologies that are very interesting that you might want to work into your full electrification plan. The products that we show here and the presentations are examples of potential electrification solutions. We don't endorse, recommend, favor, or receive payment from any of these manufacturers or distributors. or the examples shown here within. But if you happen to work from any of those, you can call me. Electric HVAC products, really quickly, how these work is your heat pump, your gas furnace creates heat as a byproduct of combustion. The other byproducts are the stuff going out the flue pipe that we don't like anymore. And then the heat pumps move heat via a refrigeration cycle, much like your refrigerator. There's always going to be two pieces to every heat pump. There's going to be a unit that's outside and a unit that's inside. The inside and outside units are joined together through a set of process piping. This piping carries the refrigerant through the system. In this particular schematic, we have refrigerant flowing through the system in the heating mode. That refrigerant flows through. It's very warm. The cooler air from your house kind of cools that air, cools the refrigerant off while it takes the warm air into your house. The refrigerant then turns into a liquid. It's pushed through an expansion device where it gets very cold. It goes outside, and the outside air, which is warmer than the refrigerant, picks up heat, and it keeps moving this heat from outside to inside. In the summertime, this little valve switches direction, and you're now taking heat from the inside and putting it outside. So we like to refer to this as carbon-free heating with free air conditioning. A lot of people, when they think about a heat pump, we've probably seen a lot of these in our travels. If anybody's gone to Europe or Asia, man, they're hanging on every building everywhere. But this is a mini split type heat pump. And this is what a lot of people think about when they think about heat pumps. And it's important when you're contacting and conversing with your contractors that you're clear on what it is you want to do and that they're clear on what it is they're going to do. There's a lot of different options. Like there's all these different types of heat pumps available. And we really need to narrow things down. Most homes in California are going to use a couple of different choices here. But there's many options, but don't let it scare you. We're going to talk about 3 different types today. Unitary, which if you have a furnace in your house now, a gas-fired furnace and an air conditioner, those are a unitary system. And what that means is you can take one unit and you can mix it, match it with a whole bunch of different other units to make a system. And that's why they call those unitary. Mini split systems are different as far as they are inverter technology that we'll talk about more in a few minutes. And then we're going to show you a couple of all-in-one or DIY solutions that you can look into. But first, a little bit about how these things work. Traditional heat pumps, or what we call the off and on heat pumps, in other words, they work kind of like your gas furnace. They'll turn on and heat or cool your house, and then they'll turn off and let your house get cold or warm again. And so typically, let's just say it's an 80-degree day in your house and you have one of these systems installed. You turn on this system at 80 degrees. It's going to use a lot of energy to start, lots of energy, like 60 or 70 amps sometimes to start the unit. And then the unit runs at one speed. It conditions beyond the set point. So if you have your thermostat set for 75, it's usually going to cool the house down to about 73.5. And then the unit will shut off, and the air now in the house is cold, but everything else in the house is still 80 degrees. So all the 80-degree stuff starts giving up its heat to the colder air, and then the air temperature in the room gets warmer. The unit turns on again, and it goes through this cycling mode to kind of get the house to temperature. Finally, after it's ran long enough, everything in the house will be kind of the same temperature, and it'll run a little shorter cycles. That's the problem with these type of systems, because since they turn on and turn off, if we size a system to be able to cool your house on the hottest day of the year and the coldest day of the year, oftentimes on those more mild times when you just want to keep the house warm and it's not terrifically cold outside, or cool the house down on a more mild day, they're way too big, and this rapid cycling can get very annoying and very costly. Inverter-driven systems, however, an inverter-driven system is that compressor that we were looking at in that diagram before. Instead of turning on and off only, it has the ability to speed up and slow down. And it also can start by using a tiny bit of energy just to get the compressor turning and get the refrigerant flowing through the system. And then once the refrigerant is flowing through the system and it's had a very soft start, it just ramps up and takes care of the load pretty quickly. And instead of overshooting the temperature, it gets down to the set point temperature, and then it starts slowing down here. So it goes up and then starts slowing down here as we get to room temperature. So instead of turning off and letting the room get warm and then cooling it off again, this unit is going to make subtle changes in its capacity as your furniture is giving off the heat, as your doors and walls and wooden floors are all becoming the same temperature. This is called the tempering phase of this unit. And you see these little lines here. So this is it's working, it's changing its capacity slowly over time to really temper the house. And you can see here on these lines where they get kind of smooth at the end, this is this point at which we reach thermal equilibrium. And thermal equilibrium means that point where everything in your house is 75. Your walls, your floors, your doors, your countertops, everything is 75 degrees. At that point, your house starts acting as a thermal storage battery because everything is the same temperature. It's going to take a lot of energy to change it, but it doesn't take much energy to keep it there. So inverter-driven heat pump systems can run much longer cycles at a much lower rate and keep the house incredibly comfortable. And most systems, say for a typical 1,500 square foot house, the energy use here is going to be about the same as a really good hair dryer. And down here, it's going to be about the same as several old school light bulbs. So when we're running in this thermal equilibrium phase, let me see if I can turn on my laser pointer here. Okay. So when we're down here in our thermal equilibrium phase, it can often run up to 6 hours at thermal equilibrium for the same amount of power you use for 1 hour of heating or cooling the house. So inverter technology is definitely our friend when we're looking at installing a heat pump in a house that didn't have one before. So inverters look great. Is that the same as a variable speed system in your quote? Now, this is a vernacular thing within the trade. So when you're getting quotes from contractors, the variable speed can mean very different things. And we need to be careful about this and ask questions. So if you've got a quote for a variable speed system, that might just mean that the fan inside the air handling unit has the ability to speed up and slow down, but it may still be working with a more on and off technology of heat pump. We want to make sure that that's verified. And you want to ask your guy, does variable speed in this case mean inverter technology? Because they should know both nomenclature. There's several different types of indoor classification, and most people that have an existing furnace, this is going to usually be the best way to go, unless you're just trying to heat pump condition a couple spaces in your house. The ducted versions are going to be the best way to go. What we have here is an air handler that takes about as much space as your furnace does. Another thing you want to make sure that you do with any contractor that you're talking to is you want to make sure that they're putting in a really good filtering system, and preferably not a filtering system that has the same label as the unit. And the reason for this is, I'm just giving you a little fourth wall advice here. When contractors put in the filtering systems that match the brand of the system, it's possible that the maintenance cost on that filter system is going to be very expensive. So we always put this unit in, it's called an April Air. And you can buy these filters right on Amazon if you want to, and you can change them out yourself, or you can get them through the contractor. But sometimes when you get a filter system installed that's the same brand, or it's electronic, or has moving parts, those are all going to need service. These type of filters here do not need any service other than a media to be changed once every half year or a year, depending on how much you're using your system. This is a mini split outdoor unit or indoor unit. This unit is a modulating unit. This is unitary, so this can be matched with multiple outdoor units. This one is going to have an exact match outdoor unit, so it's going to be a match system that communicates. These type of systems are non-communicating. The non-communicating systems can use a traditional thermostat like you have now. The communicating systems are going to need their own manufacturer's thermostat, and they are better for comfort control, but you may lose some features with the thermostat. So be careful and understand what you're getting. Then we have slim ducted versions. This is if you wanted to do a ducted system, say you have a wall furnace or a floor furnace in your house, and you want to put in a ducted system that's going to deliver cooling and heating to all the rooms. There's several brands that make solutions that can be tucked away in an alcove. Obviously, we didn't leave this like this. This is all built into a wall afterwards. And once it was installed, it looked like it was part of the house. Had a little door here for service. Or a little slim duct system in a small attic space. This might be the right solution. And it may be good to ask the customer, ask the contractor, will a slim duct system work for my house? Would that be a good solution? Not all contractors are privy to all of these types of applications. We've been doing nothing but heat pumps since 2015, and I've been doing nothing but heat pumps at this company since 2020 when we started the business. Advantages, ducted systems, single zone advantages and disadvantages. The advantage to a ducted system is it's more aesthetically appealing. So you're just going to see registers in the ceiling and an intake grill somewhere. So all you're really going to see in the house is just some small outlets and inlets for air. If you've got an existing central system, it's going to give you the ability to possibly reuse the infrastructure if it's there. It can serve the entire home with one unit. That means lower cost overall and less problems with the systems. They're generally much quieter when they're sized properly. Like most systems, you have an opportunity if you have a really noisy system, by getting the right heat pump installed to actually get a system that you can't hear operate whatsoever. Oh, disadvantages. Disadvantages, the installation can be a little bit more complex. You do have to have space for load for the ductwork. You should have a load calc done if you're going to do one of these. You should have a load calc done if possible for any of these. And then you need the correct registers. If a contractor comes in and says, we're going to put this great heat pump in, and they don't talk about the registers, mention that to them. If you have registers that blow the air in 3 different directions, those are not good registers for heat pumps. Then we have our ductless classifications. So there's a lot of different options in these units as well, including this really cool new option. This, and I say new, but these have been around for about 6 or 7 years. But this is a ceiling mounted ducted unit. This can condition a whole space up to 400 square feet. And it's very slim. It'll fit right between the studs in your ceiling, and it kind of disappears into the ceiling. These are operated with either a remote control or a wired thermostat. These are what we call floor mount or low wall systems. These can be mounted down by the bottom. In a smaller house, these are going to take up some real estate on the wall. So you just got to understand that. And then kind of the counterpart to the low wall or floor mount is a high wall mount unit. And these can be done in several different ways, like a single unit for one room. We're doing a house over in Petaluma. It's a big house with like 7 rooms, but the 2 people that live there really live in 3 of the rooms. So we're just going to put 3 of these in, and that's going to give them the heating and cooling they need because they virtually never go into the rest of the house. So that might be a good solution for you too in your particular application. The advantages to single zone systems when it comes to mini splits is the single zone units. When you have one outdoor unit and one wall mounted unit, those are always going to have higher efficiency ratings. These are great if you have a room over a garage that never gets cool, or a master bedroom upstairs that never gets cool, or a problem area that needs more heat, like a downstairs room. Any of those rooms that are having a separate climate zone within your house, these are brilliant solutions for that. They are a affordable solution. If you have a wall or a floor furnace now, you can put one of these in that main room where that wall or floor furnace is and get really efficient heating in those areas. And the way heating works is if we warm a room, warm always wants to go to cold. It's the second law of thermodynamics. So the system will semi-effectively heat the house with one unit, but it will not cool the house with one unit. But there's lots of configurations and styles. And then if your contractor is recommending something like a multi-zone system where we have one unit outside and it connects to multiple indoor units, it's very, very important that they do a load calculation and don't oversize these systems. Otherwise, they can cause some pretty crazy problems like high humidity or kind of a stinky, dirty sock smell, or overheating or overcooling a single room if you're just running one zone. The disadvantages for these, sorry, I wish I had a cough button. The disadvantages for these is potential leaks and condensation. There is condensation that's created on these units during the cooling mode, and that water is kind of inside your house and has to go outside. And sometimes that pathway can be interrupted in some way, and it can cause a water leak. These units are not going to give you very good filtration. They just have a filter in it that's not more effective than your dryer lint screen. And then they're not real easy for service. And if you have the aesthetic eye, you might not want this in your rooms. This is the multi-zone solution. You can have one outdoor unit and it hooks up to multiple types and sizes of indoor units, but it's really important that these be sized properly. So we don't want to get a unit like this that's running by itself in a bedroom somewhere that is generally larger than what you would need for that bedroom, and you're running this whole big system on one zone, because this unit will never give it will never modulate the heat. It'll always give you maximum heat and cooling, and that can be uncomfortable. So load calculations are important for this as well. Some of the advantages and disadvantages of this is you can go ducted or ductless. We do use these systems fairly often when we're doing one room. Maybe it's a room in the basement or a room upstairs, and it might have a wall mounted unit, and maybe we're doing a ducted unit for the rest of the house. That's a good solution with multi-zone. So anywhere where there's distinct temperature differentials and you don't have a lot of space outside is another reason why you would want to use one of these. The disadvantages to these are they have a lot more refrigerant in one system. So if there's ever a leak, a lot more is going to leak out. They must be operated correctly. You really need to run multiple zones at the same time in order for them to speed up and slow down like they're supposed to. Generally, when you go into a multi-zone system, you're going to get lower actual efficiencies. In other words, that unit is going to use more energy to do the same job. And then when we look at multiple single zone systems versus a multi-zone, with multiple single zone systems, you're going to have redundancy. So it's very rare that two of anything will break at the same time. If this system fails, you're not going to have any redundancy throughout the house. And they are a bit more difficult to repair and troubleshoot. So there's this new technology on the block, even newer than the other stuff. It's called the variable refrigerant flow, VRF or VRV. This is really cool because they have the ability in some of these units to heat and cool simultaneously. In other words, you can have heating in one room, maybe downstairs in the basement, and then you can have cooling up in the upstairs room if you ever ran into a situation where you would need that. Most houses might not need that. Large houses or commercial applications, these are really good for, but they are much more expensive and more complex. They use more refrigerant, and they're going to take a long time to install. Some room-to-room options for you. So if you just need to cool a room upstairs and just not going into a really expensive solution, these units called the Gradient are a really great option. It kind of, everybody knows what the old window units look like. This basically splits the window unit in two and puts the noisy part outside and the quiet part inside. And you can actually shut your window down onto it, and just this little part of the unit here is what's connecting it to the outside. So there's another box on the outside of the wall that looks similar to a wall air conditioner, and then this is the nice attractive blower and coil unit that goes on the inside. These are really good units. They're really efficient, and they're great for one-room solutions. This is another unit called the Efoca. These are both Italian right here, the Olympia Splendid and the Efoca. These are both fully self-contained heat pump system. So all of the components are inside this box, and they only connect to the outside to draw in outside air and exhaust either cool or warm air, depending on what cycle you're in. These units can be installed by a homeowner that has you're going to need some pretty solid handyman skills to put these in, but they can be installed. This one works the same way. This one is more available in the United States. Although these are both, you can find them both. And then you can go down to Home Depot or go on Amazon and just pick yourself up a nice little portable heat pump that you can plug into the room. Just know if you're going to run this in air conditioning mode, you're going to have to empty the water trough. It's going to shut off in the middle of a cycle when the water gets full. And it also needs a tube going to outside. So you have to make a window or some other opening available for that. Now this is furnace backup or resistance backup. This isn't necessary in your climate zone. So if you have a contractor that's coming in and he's telling you, we can put in a heat pump, but I really recommend that you put another furnace in with it, you need to keep shopping because this is really not necessary in your climate zone. We don't need gas backup heat. We can get a good heat pump that will operate into the lower temperatures of what you guys mostly feel in the Tri-County area. And I know inland is different than coastal, but we don't need to go with this solution. It's not a good solution, and it's usually offered if the contractor is not really familiar with heat pumps or they're not 100% confident that their solution is going to work, they will tell you to get a furnace. And so the way that these are going to work is there be an outside sensor, and it'll basically shut your heat pump off when it goes below 47 degrees and just start running your furnace, which really, if you're trying to electrify and get away from gas, is not a real great solution. There's another new product on the market. Anytime we have a push towards efficiency, a lot of smart people invent really cool stuff. And so this is a unit, if you're not interested in doing air conditioning, but you can do air conditioning with this, but it's just another part. It has a small heat-only water heating heat pump outside. It has a really big storage tank that would go in place of maybe where your water heater is. And then there's a thing called the Harvest Pod. And what the Harvest Pod does is the Harvest Pod will direct water to a air handling unit that will actually warm air with heated coils. So the warm water travels through the coil, the cooler air from the house blows across that. It heats the house up nice and evenly. And this unit also is very unique in that it can also supply your domestic hot water. For all you engineering types out there that don't like to waste energy in one direction or the other, this is a good solution. But if you want to add air conditioning to this, it's a whole completely another outdoor unit and another component up here. And these can get a little bit expensive. And I would say the downside to this product is that if the heat pump outside failed for some reason, although they're using a unit that's pretty bulletproof, if that heat pump failed for some reason, you would not have hot water or heat in the house. The kind of the thing that makes Harvest Thermal special is they're basically using that water tank as a battery. So there is some special tax considerations for using that because you can use the tax credit as like it's a solar battery tax credit. What this is going to do is it's going to run the heat pump outside and fill the tank full of hot water when energy is cheap. And then when energy gets expensive, it's going to pump the hot water out of the tank, not run the heat pump, and just run the fan and the little pump that pumps the water through. So they can save a lot of energy by generating it during the day when it's really cheap. If you have solar, you can generate it during that period of time, and then you can use that energy later on in the day. So very, very unique solution. Pretty cool systems. They're really nice. They will reduce your bills compared to a traditional gas furnace. They'll use 80% less energy than your gas furnace and 90% less emissions, which is beautiful. So really quickly about ratings, what you should look for with ratings. I think I mentioned we do training all over the state for contractors. And one of the things that we've kind of uncovered is that there's limited knowledge of heat pumps to air conditioning and heating contractors because most air conditioning heating contractors have been installing and servicing gas furnaces for 100 years in California. So the familiarity with heat pumps is small. So what we see is when they come out and give you a quote and they chatting with you about the efficiency of the system, they often talk about this term right here, which is the SEER. And probably a lot of you know what this means if you've ever bought an air conditioner. But the SEER is the seasonal energy efficiency rating. The newer versions have a 2 next to them because they're kind of more, they're not as centralized as they used to be in their ratings. But the SEER rating is basically how efficient this unit is at 84 degrees outside, the cooling at 84 degrees. Most of the time in California, especially in the coastal communities, when it's 84 degrees outside, our houses are still relatively cool and we're not running our air conditioners. The EER rating, however, is the rating of how efficient that unit is when it's 95 degrees outside. If you have an air conditioner and it's 95 outside, chances are you'll be running it. This is the number that's really important. On a heat pump, you want to look for numbers here that are going to be between 11.25 and up. 12.5 is a really good number for these. Then if they're talking to you about a heat pump and they only mention these 2 things, they don't understand heat pumps. So you need to find out the 2 other ratings. One is the HSPF. This is the heating seasonal performance factor. And this is basically the average of the energy use over the whole heating season. Anything above 10 here is a good number. If you can get a heat pump with a number above 10, you're going to be okay. If it's an inverter, you should see numbers more around 11 up. COP is the other number that's very important. And a lot of times they're going to have to look a little bit to find the COP numbers on most systems, because with unitary systems, that COP is going to change when they change the combination of pieces they're putting together. So there's this thing called an AHRI rating. You're going to want to see what that actual rating is on the combination they will be installing so that you can see what these numbers are. And all the contractors have access to those ratings. But what COP is, if any of you have ever plugged in an electric wall heater, an electric wall heater is pretty efficient. It uses 100% of the electricity and converts it into heat through a heating element. That's a COP of 1. So that means 1 unit of electricity is giving you 1 unit of heat or 1 unit of transferred energy. So the COPs you should be seeing on a heat pump should be 2.8 or higher is what we're looking for on a heat pump. And that would be at the 47 degree rating. All heat pumps are going to be rated at 47, 17, and 5. We notice on this one, the COP is 3.66. So that what that really means is for every 1 unit of energy, we're getting 3.66 units of heat. Or to speak out of it in financial terms, it would be $100 worth of electricity gets you $366 worth of heat. The most efficient furnace on earth can only give you $98 worth of heat out of every $100 of gas. COPs are going to change as it gets colder outside. So you want to make sure that the system has a good COP at 47, but sometimes, I don't know, we got to 29 this year. I don't know if it got that cold out by you guys, but 29 and 47, 29 is a lot colder than that, but it's also a lot warmer than 17. So the COP of a system at 29 is going to be right in between these 2 numbers. But with an inverter heat pump, even at 17 degrees Fahrenheit, we can still give you all the capacity you need. If you look up here, all the capacity you need to keep your house warm. The unit is just going to use more energy doing it, because remember, I told you can ramp up. So inverter technology is going to be really awesome because it's going to be super quiet, super energy efficient. It's going to make the house incredibly comfortable if it's sized right, and it's going to use a tiny bit of energy, and it's going to heat when other heat pumps won't. Load calculations. You should ask your contractor if they will do a manual J load calculation. You should ask them if it's going to include room by room airflows, and you can ask them if they need a floor plan. Those are going to be the 3 questions you're going to ask to weed out some of the guys that might not do it. Not everybody does these. There's other versions of this, but it's important when we're putting a heat pump in your house. We're now going to be heating your house with far less capacity than your furnace. So we have to know what the actual load of your house is to match the heat pump up with it right. And it's not a big deal when well, it kind of is, but if you have an oversized furnace in your house is just going to get really warm really fast and shut off. But with a heat pump, if it's oversized, it's going to cause problems. So we need to make sure that it's sized right. So load calcs are important. We want contractors to do them, but not all contractors do them. So just be aware of that. Some coastal considerations. You want to protect the equipment from the elements. If you're right on the coast, put the unit on the side of the house so it's not getting the prevailing salty wind into it. Look for premium manufacturers on this equipment that have the protective coatings on the coils. The coils are going to be outside and they're made of aluminum, and aluminum is not always great when it's next to a seacoastal climate. So there are companies that put a blue fin coating on them, and that's 1,000-hour salt spray certified. So those units will work well in your climate zone and your kind of coastal, beautiful coastal, I'm envious of where you guys live, zone. We want to make sure that you have proper draining of the outside condensate. This is something that you need to ask the contractor. These units will shed water when they're running in the heating mode. And so if you're putting it on a pathway or something like that, it will get that pathway nice and wet when it's running in heating mode in the wintertime. And that can create a slipping hazard or something like that over time. So we need to make sure that most of the units have some sort of a diversion pipe or something where they can usher the condensate off to a different area. Vapor barriers. We need to make sure that the vapor barriers are intact, and that you're selecting your system for the proper humidity. Although a lot of studies have been shown in California coastal areas, we don't have a terrifically high humidity. It's very momentary and slow, and it's usually when just the fog comes in. So let's get on to electric water heating stuff really fast. There are some solutions for electric water heating and other types of water heating that most people are not going to deal with. Just give you a minute to soak that in. If you don't have hot water on at your house, you go to some extremes to get some warm water going. So a heat pump water heater. Heat pump water heaters are the best electric solution for water heating. They are very, very energy efficient. In fact, most of them will operate for about the same amount of energy as a big refrigerator. What they do is they take the ambient air in. So if your heat pump water heater is in the garage, it's just going to be pulling garage air in. It's going to squeeze all the heat out of that air. It's going to condense it into the refrigerant, just like we were talking about on the other slides. And that refrigerant is going to heat the water. And most of these systems are going to be a hybrid heat pump water heater, and those will also have electric heating elements. So if it gets a little cold in the garage, or the ambient temperatures get low, or you drain a lot of water from the water heater quickly, the electric heating elements will help it recover faster. Heat pump water heaters will not recover at the same rate as a gas water heater, but they are tremendously more efficient than a gas water heater. Several brands. Right now, there's only one brand that has a 110 volt plug-in model. So this is really cool if you've got a lot of electrical loads going in, your panel's kind of at capacity. You can plug this right into your electrical circuit and it will run. This model does not have backup heaters. So if you get a 110 volt model, you either have to be very conscious of your water use, or you need to go with a bigger tank. So I would recommend, if you're going to go with one of these, to go with a 65 or an 80-gallon tank, even if you don't think you need it, because when you take a lot of warm water out of here, it's going to be replaced with cold water, and it's going to take this unit a long time to recover. These units here all have the electric heating elements behind here. These are very different too. Brand is going to dictate location. So if your unit is going into a very tight spot, you're going to want one of these units that has the plumbing that comes in from the top. And so you don't have to pull a bunch of piping and everything around the sides of these. These units can get very busy with all the piping that's connected to them. These two brands right here, this is the one I like the best. These two brands right here are both top load. This particular one will top load or side load. This one also has a very unique feature. When we're drawing the ambient air into this and pulling the heat out of it, the exhaust has to go somewhere. On this brand, the exhaust is in the front corner. On this brand, the exhaust is in the back corner. So this one, you can't be pushed up against a back wall. So if it's going into a small space, this is not the brand you want to install. If it's going into a small space, like very cramped quarters, this unit exhausts the air and pulls the air in from the top. And this can easily be ducted to another location. So this one is a great solution if it's going into a smaller closet or a limited space. And when I say complicated, this is the typical plumbing on one of these water heaters. This is not a DIY project. We get calls all the time from people that like, I bought this water heater, I brought it home, I took the box off of it, I read the manual, and it is way out of my league. And you might find a contractor to install that, but if you do that, you're not going to have a warranty. You have to buy it from the contractor if you want the contractor to honor the warranty, just as a note. But there's a lot of different things here. We've got piping coming out in all different directions, and you can see all the extra space this thing takes. If this thing just had the water coming in here, the electrical coming in the top, and one drain on the side, it would take up a lot of space. So this particular closet location where this unit is in would have been better suited for a top loading model. How quiet is your lifestyle? If you live in a really quiet house and you like to sit and read in quiet, and the water heater is right behind you in the wall behind you, and it's a heat pump water heater, it's going to drive you insane. So it's important that you ask yourself this question and that the contractor explains this to you. They should be asking you, is the system sound going to be objectionable to you if this unit goes in close proximity to where your living space is? If you have the water heater built into a closet inside the house, you should consider this a lot. The model here that I showed you, here is the quietest version available, and it can be ducted, but it's still going to make some sound. If you have an absolute quiet lifestyle and you don't want something in there that could possibly or potentially drive you insane, this is the solution. This is a split system heat pump water heater. The noise making part, which is still very quiet, goes outside, and then it's actually plumbed into a tank that makes absolutely no sound. This unit this actually solves a lot of problems with heat pumps as well. One of the problems with heat pump water heaters is it needs a 30 amp circuit and 230 volts for if you want the hybrid model, which is the better one. This is only a 15 amp system. This is also an inverter compressor in here, so it speeds up and slows down. So as you use hot water out of this tank, it will give you as much hot water as you need to refill that nice and smoothly. And sometimes it can do it using a fraction of the energy. But if you have the family come in for the holidays and a bunch of people take showers and you take a lot of water out of here, this unit will actually heat water from 55 degrees to 150 at 1.7 gallons per minute, which is really an incredible recovery rate. And the larger the tank you put in with this, it also improves your recovery rate. These tanks typically come in 43 gallon size, which would be equivalent to a 40 or a 50. They come in 83 gallon size, which would be anything above that. But if you're going to have a lot of usage on the system, I would go for an 83 gallon if it'll fit, because the cost differential is minor. And the more hot water you keep there, the less that system is going to have to run. They also have 119 gallon tanks. And if you have, say, a multifamily property that has 3 or 4 water heaters in one closet, you can put in a 119 gallon tank and one of these and provide enough hot water for multiple other hot water heaters, or just water heaters. There is also the electric tankless. People ask us about the electric tankless all the time. These are not practical in a whole house. These use an incredible amount of energy. I don't know if you can see where all the wires connect on here. There's 3 separate electric burners in here, or electric heating elements. This thing needs 4 30 amp breakers to be, or excuse me, 3 40 amp breakers to be attached to it. This unit at peak, when the water is really cold and the demand is high, this unit can use 100 amps of power. So not a good thing to put in. If you've got an existing tankless water heater and you want to replace it, the best deal is to go with a unit like this and just put the tank outside someplace, build a little enclosure out of it. Okay, so I hope that was helpful. that is the end of our slides. And now we have 10 minutes to take some questions.
All right, thanks, Larry. If everyone wants to, if you have outstanding questions, feel free to put them in the chat. And in the meantime, Larry, I'll start with the one question I haven't answered so far. I believe Andrew had a question about whether Bryant is considered one of the premium manufacturers. I think that was with respect to the slide we were talking about coastal considerations and coatings.
It's going to depend on if is it the Bryant inverter ductless system? We don't know that. So Bryant is a good product. Bryant is made by Carrier. It's a good product, but you are going to have to check and see if it's been coastalized. And so some of those models come with a coastal coating put on them, but also your contractor can send that unit out and have it coated. So if you have a coated coil in a coastal environment, it'll last twice as long.
Okay, a couple more came in. Andrew clarified that it was a ducted system.
Okay.
Let's see. Jim asks, what was the water heater on the right that you preferred? I assume that was either the Sanco or the State Smith unit.
Yeah. Okay. We'll pop back to that slide real quick. So these are various manufacturer names. So these are the Proterra line from Rheem and Rude. And these are really, really good water. I have this one in my house. I have the 115 volt plug-in in my house. And it's a 65 gallon. It works good. We have learned a couple of hard lessons with it on a Sunday when my wife did a lot of laundry and we took several showers and I ended up with a cold shower. And it took 7 hours for the tank to recover because we blew through 65 gallons of hot water. These are going to come in two different models. The Rheem and the Rude are all going to be side load. So they're all going to have the upper and lower plumbing connections that have to have all that piping wrapping around them. This model here with the top loading right here is called a Bradford White. This unit is also made in the United States. It's a really good unit. These units have better controls on them than the Bradford White does. If you want to use a interface module with the Bradford White, at least the last series that we installed, you have to buy an additional piece that plugs into it. That gives you the ability to do what these units can just already do. This unit also has the fan coming out of the back, so you got to be real careful about not pushing it into the back of a closet or in the back of a space. This unit here is two different brands. It's called State is the contractor brand, and A.O. Smith is the other brand. So all of these units are going to come in 50, 65, and 80 gallon sizes. It's important to know the larger the tank you buy, get a bigger tank than you need because it's way more efficient if you have a larger tank. So just really quickly, I'm going to digress for a second. If I have two people in a row take 10-gallon showers and I have a 50-gallon water heater, I've effectively used 40% of that hot water that's in that tank. That means 40% of the new water that's going into that tank is going to be cold. That means that this unit is going to have to work hard and it's going to have to switch on the secondary heaters in order to heat that water back up again fairly quickly. If you have a larger tank, say a 65 gallon, and you take 20 gallons, you're using only 30% of the tank. And so it doesn't take as long for them to recover and they use less energy. The other thing that you should always insist that the contractor does is install a mixing valve on these units. So we put these little valves up here that allow us to run the tank temperature up to 140. And we know we don't want 140-degree water coming out of our kitchen sink or our shower, right? Because that would hurt. So the tempering valve, what it does is it mixes with cold water and it reduces the temperature of the water coming out to 120 degrees-ish. And then you can adjust that a little bit in the field as well. But when you have 140-degree water standing in here and we introduce 50-degree water into there versus 120, that water, just the heat of the additional water that's in there is going to temper that water more quickly and shorten the recovery time. So largest tank you can get and run it as hot as you can, put a mixing valve on it. Those are the three things to make you can hypermile the performance on these heat pump water heaters.
Okay, Yeah, Larry, you want to pull back to this slide. So the questions are pouring in. If
Okay.
I'm not able to get to your question, feel free to shoot us an email after the fact. Our email address is listed right there. But yeah, we can go down and try to rapid fire some of these. Cameron asks, heat pump water heater without an outdoor condenser wouldn't make sense in a basement where it would spit out cold air under the house. That would counteract home heating, correct?
Not usually. I mean, the capacity of these water heaters is very small. In fact, most of them are only 5,000 BTUs. And so it's not going to make a measurable enough difference. Although it may make sense, if you're concerned with that you could run a vent off of the exhaust side and just vent it to the outside somewhere. So, and that would give you a nice little ventilation loop in your basement as well. But I wouldn't worry too much about that.
All right. Claudia, what's the best way to find a knowledgeable contractor? Great question.
The best way to find an eligible contractor is to go on the 3C RIN contractor finder and look for contractors that are on there. There's also a contractor finder called the switcheson.org. And those contractors that are listed on there, you can look them up by zip code and you can find whoever's servicing your area. And they have a nice feature on there, as those contractors will tell you what they're doing in there. So you can kind of weed some of them out. Maybe your house needs insulation and one of those contractors listed on there doesn't do insulation. Maybe that's not the guy you want to call. But those two resources, cross-referencing those two, should get you into a pretty good contractor. And I believe that you can just call over or you can engage with 3C RIN and they can recommend a contractor for you. Probably 3. Most of them do 3.
Right. And the other things I would add are, feel free to reference some of the topics that we discussed here today.
To interview.
Yeah, exactly. During the interview process, it's about, whether they have familiarity with load calculations. If they offer more than one heat pump type, that's an important question to ask. And we also have another recorded training with 3C RIN that we did, I think, a month or 2 ago, on kind of the whole customer journey and phasing some of these things. There's a lot of good content in there that you can use to well-informed questions. Okay, next question. Where should the outside unit be sited?
That's going to depend on where you are and what the local ordinances are. The inverter systems are going to be much smaller than a unitary solution, so they can get tucked up against the wall a little closer. So if you have a 4 or 5 foot path on the side of your house, and the city says it's okay to put it there, it's going to give you the ability to drag the garbage cans around it or the lawnmower or whatever, right? So it's going to give you a little bit more space. That's another nice advantage of those. But you want to put it within a decent proximity of the indoor part. Most of these systems can be 50 to 60 feet away from the indoor location. Some of them can be 100 feet away, depending on the system. But you want to make sure that if it's going to go far away from the indoor unit, that the installer shows you that the unit can do that. Because once you get it installed, you don't have a lot of recourse to get anything fixed.
Okay, next question. Separate tank seems like it'd be best. It's our gas water heater and corrodes from the hard water and lucky to last 10 years. Hopefully the heat pump part is less susceptible.
It is less susceptible. And so part of the reason for that is the gas water heaters kind of wear themselves out. There's an intense amount of heat on the bottom of that gas tank when it's warming from the bottom. It's just like a pot on your stove. After a while, the pots on the stove get black. But that intense heat up there is what's heating that water up really on the bottom, and it's kind of rising through, and that can separate the minerals from there and cause things to go bad. And you want to make sure that you check the rods that go in there. I forget the sacrificial anodes, and make sure that those are dealt with. But these Sandco tanks on that split system are actually stainless steel interior tanks, and I think that they have what's the guarantee on those? Alex, 15 years, I think. Yeah, the tank is guaranteed for 15 years.
All right. Next question. We have to replace the furnace and the ducts. Is it better to do a mini split or a whole house built-in system?
If you want to do the whole house, it's better to do the whole house system. But you can use the mini split inverter technology with the whole house air handler is going to be the best, most efficient way to go. You can also get unitary equipment with the really high ratings, but it's going to be much more expensive than the mini split based stuff that gives you the same ratings. But if you can reutilize your ductwork and you don't want to have the units on the wall, but that being said, if you are only living in part of your house and just part of it needs to be heated or cooled, a ductless solution can be good for you. You want to talk to a contractor who's going to be able to talk you through all that.
Okay, next one. We live in an area where it can get below 20 degrees at time. Well, a decent heat pump bring the house to 68 degrees when it's very cold outside. I replied to this one saying, yes, as long as it's sized correctly and the unit is properly selected. We have lots of solutions. There's heat pumps running in the Arctic right now.
Yeah, absolutely. There's heat pumps running in the upper Northwest that are running in 0-degree temperatures in the winter. They just need to be installed properly, sized properly, and make sure that they're picked out properly. And then, you know, if you're going to have one of these put in, have the contractor guarantee you that it's going to work, right? And then you have some recourse if it doesn't. And you can also look for a cold climate model. They're high heat output models. They make those as well, where they'll operate efficiently down to -10 degrees.
So folks, I hate to interrupt this wonderful conversation, but we are at an hour. I will go ahead and make sure to send the slides, the recording, and I'll work with Larry and Alex to go through and grab some of the questions that weren't answered and do our best to send some resources to answer your questions. On behalf of 3C Ren, thank you very much for attending today. If you are interested in connecting with a contractor shortly, that information will also be in your email. So take care all. Have a wonderful rest of your day.
Thank you, everybody.